So let's end this section by doing an example of a change of variables in three variables, right? So when you guys talked about spherical coordinates, you probably did an example of finding the volume of an ice cream cone or something of that sort, right? Well, here we're going to do a variant on that. The ice cream cone is now elliptical, right? So it's wider in one direction than another. So you get more ice cream. Of course, that's better, right? Anyway, so how do we do this? Well, you used spherical coordinates last time. That worked great for a sphere. We have an ellipsoid, not quite a sphere, right? But what an ellipsoid is you take a sphere and you kind of stretch it or scrunch it in some directions. So all we really have to do is undo that and turn it back into a sphere. And change of variables lets us do that. So let's start by looking at our equation for an ellipsoid here. All right, so we have x squared over 4 plus 16y squared plus z squared over 9 equals 1. All right, so there's a bunch of mess in here. But let's rewrite this. This is really x over 2 squared plus 4y squared plus z over 3 squared, right? If somehow this over 2, this 4, and this over 3 weren't there, it would look just like a sphere of radius 1. Well, here's where change of variables comes in. We can say, well, let's use a more striking color difference here. We're going to take this guy and we're going to call it u. We're going to take this guy, the 4y, and call it v. We're going to take this, and you guessed it, call it w. And then, if we do that, well, we get an honest u squared plus v squared plus w squared equals 1, a sphere. What about the cone here? Well, we have to use this u, v, and w now, so let's see. Well, let's write it back down here. So we have z squared is 9 x squared over 4 plus 16y squared. Okay, well, we already know in here x squared over 4 is just u squared. 16y squared is just v squared. What about the z squared over here? Well, so if we actually write out u is x over 2, v is 4y, then w is z over 3, which means that z is equal to 3w. So here you'd get 9w squared. And so these 9's cancel. Right, you could also just take this 9 and divide it over. So we have w squared is u squared plus v squared. Oh look, that's exactly that regular kind of cone again, right? And this cone, the top part, is described in spherical coordinates with phi equals pi over 4. Right? Because remember, phi starts up top and then falls down. Okay? So, what do we do now? Well, we have to start finding this volume, right? So what is the volume integral? Well, you're just integrating over your solid dv, right? So when we do this change of coordinates here, what have we changed to? So let's say E here is the elliptical ice cream. And let's say S is the spherical one. So this is the one with u squared plus v squared plus w squared is 1, and w squared is u squared plus v squared. Okay? And then this is the guy given in problem. So we'll just say given. Right? So, well then, change of variable says we can just switch to an integral over s now, but dv is going to have to change. All right? So what needs to go in there is the absolute value of d x, y, z, d, u, v, w. Right? And then we'll say d, u, dv, dw. Right? So we need to compute this Jacobian. Well, we have our u, v, and w right here, and they're given as functions of x, y, and z. Now we could very easily solve here for x, y, and z. So let's actually do that this time. X is 2u, y is 1/4 v, and z is 3w. Okay? And now to compute the Jacobian, dxyz, duvw, well, it's the determinant. Now it's a 3 by 3 matrix. So we have to take the derivative of x with respect to u, then v, then w. So with u it's 2, v at 0, w at 0. Right? Now y, with respect to u, is 0, v is 1/4, w is 0, and then z, 0, 0, 3. Right? So the determinant of this, since there's zeros everywhere but the diagonal, it's just the product, and you get 3/2. All right, so you can check that. So that means now we get, now we take the absolute value of that, but it's positive. So this is the triple integral over s of 3/2 du, dv, dw. All right, well, unless you remember the volume of this regular ice cream cone off the top of your head, this is still going to take a bit of work. What do we do now? Hopefully you're thinking we actually have to go now to spherical. All right? So in spherical, how is this described? Right? So in spherical coordinates, this is actually a box. So take a second, think about how you describe it, and then we'll come back and finish this off. All right? So how do we do it? Well, this S here, we want to describe this in terms of rho, theta, and phi. Okay? Now here, u, v, and w are playing the roles of the usual x, y, and z now. Right? So rho will go from 0 to 1. Theta, well, it's the whole way around. So 0, theta, 2 pi. And then phi, well, we start all the way at the top, and then we fall till we hit the cone. And this cone happens to have phi equal to pi over 4. So we get this for S. Okay? So now we have to change to spherical. Right? So we keep our 3/2. Now this guy here is the old dv, right? Because remember, u, v, and w are acting like x, y, and z would. So we get our rho cubed, rho squared, rho squared sine phi. And then now we have to decide the order. But there's not much to that, right? So let's do theta first, just to get it out of the way. Then d rho, d phi. Okay? So theta goes from 0 to 2 pi. Rho goes from 0 to 1. And phi is 0 to pi over 4. Right? So if we integrate this, well, with respect to theta, since it's 0 to 2 pi and there's no theta here, all we're going to do is multiply by 2 pi. So I'm going to pull out the 3 halves and the 2 pi, and that's going to give me a 3 pi here. Right? And then we go from 0 to pi over 4, 0 to 1, rho squared, sine phi, d rho, d phi. Right? Now, when I integrate with respect to rho, I'm going to get 1/3 rho cubed sine phi from 0 to 1. So all that's going to do is contribute a 1/3. So I just have pi, 0 to pi over 4, sine phi, d phi. All right, now I integrate that, and this is going to be pi, or negative pi cosine phi from 0 to pi over 4. Right? So let's come back up here to finish that. Negative pi times, make sure that's clear, negative pi times, well, cosine of pi over 4 is root 2 over 2. Cosine of 0 is 1. So this is pi times 1 minus root 2 over 2. And that's the volume of this elliptical ice cream cone. Right? So I know we've produced a big mass of things, but this has two concepts I wanted to show you. Right? So first, it kind of illustrates how to set up a change of variables in 3 variables, which you, of course, already done 2 examples of with cylindrical and spherical. But it also showed you that you can chain these change of variables. Right? So think of, sometimes when you're doing u substitutions, you would do one u substitution and find out enough I need to do another. And that's pretty exactly what's happening here. We did this change of variables here, right? But then we found out, oh, wait, this is still something I can't integrate with sort of Cartesian coordinates. So you need to do another change of coordinates that takes it to something nice, right? So you could have actually combined both of these into one if you try hard enough. But sometimes it's just easier to take it one by one. Other times it's easy enough to see that you can just do one or do the 2 combined together. But so I encourage you, practice this stuff, do many examples of this. This change of variable stuff is sort of the first really big theorem from Calc 3. Right? This is your first big scary theorem, so to speak. It's really not that scary either once you've gotten the hang of it. Right? So before I keep talking, let me just end it here and say I hope you've enjoyed this section, and see you in the next one.